Hello, welcome to today's data video. I'm going to take just a little while and talk about a concept that's come up for discussion multiple times within any data warehousing environment where you have reporting or developers or anybody else that's concerned about the data. And that is, what is a snowflake and how would I use a snowflake? And is a snowflake good or bad? And what that does is brings us into the discussion of the star schema versus the snowflake schema. What's the difference and how do you choose the right one for your data warehouse? So just take a look at where this came about is that our Daisy Hill data analysts have begun to stretch out their knowledge by following along my videos, inviting me on discussions, and they started hearing about star schemas and snowflake schemas as part of the Kimball discussion, and they wanted more information. So I said, okay, I'll come along and I'll give you some ideas to have your discussion because by the end of the day, there really is not a solution to your question. But there are certain things to be considered when you undertake this kind of discussion and decide how to design your data warehouse structure, primarily how to design or whether to design a data mart as opposed to something else. And we'll talk about actually these 4 points along the way when we look at the design of a snowflake as opposed to a star. And that is generating your data and maintaining your data. What is the impact of one versus the other? How do you want to deal with them? So everybody's like, oh, it looks pretty. I like the way it works, but I have no idea how to get the data into one versus the other. So that's always a good place to start. Second thing you need to look at is how complex is your queries going to be when you try to access the data that's within this data mart. And can you live with that? How sophisticated are the people? And it's just something to be under consideration. The third point that we're looking at is how does your reporting tool access your data? What is the methodology by which you define your data source to your reporting tool? And is it designed better for a star schema, a snowflake schema, or even just a relational schema? Because again, all these are relational structures, just a simply different environment. We were working with a tool many years ago to where they really recommended that you use a star schema because it made it easiest to define the elements and to join them together. And it took us a while to understand that they did not mean they could not absorb a snowflake schema. It was more easy to take in the star schema. And in that case, just as a side point, we ended up building the Snowflake schema because of data generation maintenance. We were really under a lot of pressure to get data into our data warehouse, and doing it and putting the data in via a Snowflake schema was much simpler than going to the star schema. So we went that route just to get data out there. And then finally look at performance. How performative is the data through the tools that you are using under any of these structures? And you can't really answer that question until you begin to see how the data is being accessed and how well the database underlying structure will support it. And along those lines, there's been many discussions over the years that a Teradata environment really relies upon a third normal form in the Inmon construct because it does the best performance. Well, guess what? A very large data management system with lots of power can process any of these structures mostly efficiently if you simply design the underlying structures as far as primary keys, foreign keys, etc., to get the job done that you need. So you really can't say one versus the other gives you the best performance. It has to do with the amount of data that you have. Some of the Oracle RDBMS parameters that you can set is to make it more efficient for a star schema than a relational schema, and so therefore even a snowflake schema would not be inherently more efficient in that environment over a star, because you can actually tweak the query performance to be geared towards star schemas and always make the assumption and work better that way. But that being said, let's look at our data from a design standpoint, and we will bring up my SQL DBM data modeling tool. You have probably seen this or should have seen this through my other videos. You can look through them and see where this came about. But at one point in time, we were looking at the puppy performance data, and we looked originally at how it was stored in their transactional system. So again, transactional system designed for getting data in, getting data out, and showing you what you have in data entry, etc. So they're built in a very normalized form. And if we were to look at the puppy performance relational system from the application, you have your parent tables, and then finally you actually have your performance table down below, because a puppy is a parent table to the performance, but the breed and the kennel are also parent tables to puppy. And then we also have the other relational tables of costume and trick that feed into puppy performance as well. So very easily we modeled this and saw how the data was implemented so that we could decide what to do with it. One of the choices we made was to go ahead and do the Star Schema, and we put that in our dimensional model here. We built a little data mart around this. This is a Star Schema because it has a fact table in the middle, and it has all of the dimensions populated around the outside. And so what we did is took that relational structure, broke it out into what is dimensional data and what is the actual facts. In this case, we only had one fact that we dealt with, which was the performance duration. Everything else became part of the dimensional structure. So the ease of, we talked a little bit about data generation. This is actually a little bit harder to generate this type of data because you have to break out the relational data and keep that information that's associated with relational data somewhere available so that you can put it into the actual fact table and generate the individual dimensions and then link the dimensions together as well. Now, if we were to do this in a fully Snowflake schema, we would build something slightly different. And along the way, we'll talk about how you would generate the data and how the data generation and maintenance is affected by the design. So let's pull up our Snowflake. And very easily, when we look at the data that's out there, we can see the top level dimensions that we had. And those happen to be the fact that we have the kennel dimension, the breed dimension. We have that overarching date dimension, costume dimension, and trick dimension. All are easy to see because they were at the top level of our relational model. But now we come into other pieces of the data where we made separate dimensions or need dimensions, and we would add them in here. So for example, we would want to have into this a puppy dimension, which we have talked about before, but this is going to be this puppy snow dimension. And how this differs than the original one is the fact that rather than just simply being, in the previous case, in the star schema, the puppy dimension just simply had its warehouse ID, which is a big integer. It then had the puppy name as a piece of descriptive information. And we'll just make this 45 since that popped up. So this was our original style of our puppy dimension, but since this is now going to be a snowflake, what we do additionally is to go ahead and bring in its parent relationships as well, hence creating what is going to begin to look like what they call the snowflake. And when we do that, we've now established this relationship between these. We need to modify their names, and rather than the kennel warehouse ID being part of a fact table, it is now part of a dimensional table. And this is where you violate that strictly star schema and you begin to build the snowflake. The second one here is the breed. And just keeping some kind of order involved here. So now our dimension is not just descriptive information and it's identifying information, it also is the relational information as well. We would also want to do the same thing for the performance dimension, which before was a degenerate dimension that just simply had an ID for us to reference. But in this case, the puppy performance snow dimension fits in here. And what we end up having is its ID. And if you remember, there is nothing that specifically is used to identify the performance dimension. But in this Snowflake, we now need to bring in all of its parent tables. And remember, we had a date in there. Well, date is one of our dimensions, so we'll bring in the date. We'll bring in the costume. And we will also bring in the trick. Modifying these. It's the date width. This is the costume width. And then finally we have the trick width. Give these a little bit of alphabetical ordering. So now we see that our dimensions are a little bit more complex. Now it's easier to manage these two dimensions as well as the parent dimensions because they fit exactly in with the relational data that is being fed to us. And so from a data creation and maintenance area, it's a little bit easier. But let's talk just for a moment about the fact table that we'll need to put in the middle of all of this. So we want to go ahead and bring or create our fact table, which in this case is puppy performance snow fact. And what it has associated now becomes a bit simpler to generate because it has two dimensions that feed it as opposed to the multiple dimensions that fed it before. And you can now see how this looks more like a snowflake than an actual star. Let's go ahead and modify these. This happens to be the puppy width. And this one is the puppy performance width. Both of these are part of the primary key. So we drag them up above the line. And then our only metric happened to be the performance duration value. And we're going to make that a big int. So it becomes a much simpler fact table, and it's surrounded by a more complex dimensional structure. So again, populating this and maintaining this is pretty simple. We only need to have information about the two directly feeding dimensions. But one thing to keep in mind is change over time. And I always dislike bringing that up, but it's a very important discussion that need to have whether this is a snowflake or a star. What happens if the kennel that owns the puppy changes? Do we want to change the puppy performance fact table as well? Because since the puppy dimension inherits a value from the kennel dimension, should this puppy's kennel change, it will be reflected in this relationship, and then this data needs to be updated. But by default, when we begin to query the performance data, we will always see the current kennel as opposed to the kennel that was there at the time of the performance. If we want to maintain the kennel associated with the puppy at the time of performance, we have to go to some type of slowly changing data and information that needs to be modified to change. Now we go back to our dimensional model. You can see that if something changes within the puppy itself, it is not reflected in this data mart, because if the puppy has a new kennel associated with it, it doesn't affect the current performances or the old performances. It only reflects performances that occur in the future, so that when we build the new puppy in puppy performance record, it will reflect the current puppy in the current kennel. And sort of the reverse holds true as well. If you want the kennel associated performance to always reflect the puppy's current kennel, then should this relationship change between the dimension of kennel and puppy, then you have to remember to go in and modify the fact table to change the information for the kennel at the time the puppy changes. Now that is also a bit difficult to do, and so that's where you have the ability to trade off one versus the other by knowing what it is that you want to do with the data going forward. So in the truly star schema, the relationship between these two does not exist, so therefore the data stays static should that relationship change, as opposed to in the Snowflake, that relationship exists, so therefore should that information change, it will automatically reflect it in the target data. The next item we'll talk about is query development. One of the issues that you run into with your more junior population, if they have to write SQL select statements, is it can become confusing or tedious to understand how to rationalize this structure in a select statement. Because what I would have to do in such a select statement, that's not my text tool. Here's my text tool. So from a relational standpoint, if I want to select whatever from the puppy performance snow fact, I'll then have to join it to the puppy dimension, and I would be using the puppy dimension that would point to the fact table. Then want to see kennel in here as well, then I would want to join on the kennel dimension, and this would now be the puppy dimension pointing to the kennel dimension, or if we're going to keep the same nomenclature, the kennel dimension relationship to the puppy dim. So I begin to have to navigate from relationship to relationship to build that select statement. But one of the reasons why Kimball enjoyed the star schema is that if I do the same thing, if I query my puppy performance snow fact, and I want to join it to its dimensions, I join puppy dimension, and I on the puppy dimension pointing to the fact table. And if I want to bring in the kennel dimension, it also will be on the kennel dim attributes that point to the fact table. And that's the same for any dimension. In the star schema, it would be the always reporting back to the fact table. So this, to a degree, makes it easier to generate your query statement understanding just simply one-way connections with the relational structure. As opposed to the Snowflake schema, you begin to have to navigate back upwards and through the schema itself. So again, if we want to get all this data involved, we have to understand all of these relationships and where they are and how they join them, as opposed to in the strictly dimensional model, everything joins to the fact table. Now, the caveat we talked about before is how is it that you design and utilize your data query and access and reporting tool? Do you have to develop your SQL yourself? Does it automatically find relationships? Is it designed around a star? And do you do drag and drop in order to do something like you would do within Access? If I create a new query designer, what I would do here is, in this case, as you drag and drop in, you then have to identify how to relate these together. So you would have to be modeling whatever the structure is and which of these makes it more readily understandable by your business community if to whether they are dropping in a structure such as your star schema or trying to figure out how to drop in the structures of your Snowflake. And again, that depends on your populations and how sophisticated the tool is and whether or not it is seen to be very easily dropping in a star schema or a Snowflake schema. There are some tools that are assuming that you're dropping in a star schema and make it easy to go that way. And then finally, we talk about performance. And remember, always address performance when you run into the problem of performance and not ahead of time. Because when you're talking about a relational system, is it easier for that relational system or more performant for that relational system to digest a fully normalized structure such as this because you have multiple indexes associated with the data, and it can pull in subsets of data before doing the final join of data again? All this depends upon how much data you have and how the execution engine decides the pathway through and where the best resources will be utilized. And from the side standpoint, one of the reasons why we like to use something such as Alteryx is because Alteryx becomes independent of the RDBMS, and because no matter which way, whether Alteryx is being used to join the data within a strictly star schema, it only joins two data paths at one time. So if I was to generate the query inside of Alteryx for this structure, I would decide to first bring in these two data streams, join them together, and then begin to add one stream at a time into the combined solution of this data, and it would work very efficiently no matter whether it's in this structure, because this structure I would do the same thing. I would start out with my performance fact table stream and my puppy stream to begin with, and then I would bring in the kennel and the and the breed and the performance, etc. So I would bring in one of these streams at a time and join it to the existing stream. So in that standpoint, the development of the stream is no different whether it be a snowflake or a star. It's just simply how you perceive having to bring that data in and how to understand when and where to bring the data in. And from a performance standpoint, it really would not matter. So now I realize that I have not given you an answer. We have discussed these different points: data generation, complexity of query, the reporting tools access, and whether or not performance should be an issue. So the wrap up is whether you build a fully relational structure in the nature of Inmon, use the Kimball's clean and direct star schema or his hybrid snowflake structure. They all have benefits and costs. You adopt the one that makes the most sense for your environment, but at least knowing what the issues are associated with them and knowing how to build them and what they look like and what they are telling you different from each other is a point to have a discussion. And over time, it becomes an art as determining which structure makes the most sense for which piece of data you are currently using. I hope this helped you understand a little bit more about these two structures and to make decisions on your own. Please subscribe to my channel so you can see future discussions that I bring out. If you have any questions or comments, please put them in this stream or drop me an email. If there's something else you'd like me to show you, I'll be more than willing to take a look at all of your comments and suggestions and help define where we're going from there. So have a great day. I hope you enjoyed this. Thanks for watching.